Okay, we're going to go ahead and get started here. We are looking in at Chapter 10, Classes in Object-Oriented Programming. And this is kind of where you will take kind of a major, kind of paradigm shift in your programming, because here's the key idea of objects. You're no longer programming for the end user. So I don't care about any of the user kind of like extreme user input that you would need for these classes. When you actually test and drive them, you can just literally put the values in. So and that's where a lot of students have the biggest problem, is that paradigm shift, that you're no longer authoring, you're no longer writing code for an end user. You're now writing code for another programmer. And when you get that code built, then you just drive the code and test it. So try to get out of that paradigm shift of that end user in your thought process as you're actually learning about objects and working with them. And once, and it's only some students that kind of have an issue with that, but once you get beyond that paradigm, the objects start gelling for you a bit more. One of the main things of object-oriented programming, it kind of takes and it adds to that idea of divide and conquer, which is why we have functions. But in this case, the problem with functions was that you always had to send the data to the function and get the information back from the function. That's like, okay, well, let's pretend that the data is a watch and the function is the factory. Should I send my watch to the factory to get it to change the time? No. And that's the idea of objects, is that now we can have one contained unit that we give a name, and it has the data and the functions with it that act upon the data to give you the answer. So you're getting the watch and the factory in one, or basically actually just a way to change the time on the watch that you bought. But that's the idea of objects, is that you now have you can call it a box, and in that box you have that data and those functions to act upon that data. And that's all an object really is. And that's actually really kind of improved programming, to the point where, I always tell students that the difference was I would get new hardware and have to wait for a year for the software to be written. Once object-oriented programming became mainstream, the software was already written for the hardware. And sometimes even the software was written before the hardware was even dreamed of. No, well, not really. But anyways, it just totally, axed that issue. And software development really, as far as the time it took to complete development, really decreased. One thing that about those objects is the data and the procedures. One thing about it that we also kind of like to do is, if I'm giving somebody, it's called encapsulation, and combining data code into a single object, that's encapsulation. And then we got also the idea of protecting that object. So when you give somebody the keys to a car, it's called information hiding. The person just wants to get in and drive the car. They don't, if you're going to give a car object to somebody, they just want to get in, use the object, and drive. They don't want to open up the hood and see all the nuts and bolts. So that's kind of the idea of encapsulation. And it's extremely helpful to build libraries that are safe to use, especially if maybe that library accesses hardware that may cause a safety issue. And you would want to write software that allows somebody to write their own software on your hardware. And you would want to give them a tool that was hardened and protected against that sort of capability. Okay, so I don't want to. We're going to get into that part of encapsulation, but the other part of it is the data hiding, and that's where you have your hood on the car. You hide the engine and the nuts and bolts. So we're going to get into actually, because I don't want to spend too much time in these PowerPoints, because I want to actually show you how to build one. But some of the vocab is fairly important, and one of this is when we say an instance, an object created from a class. So when you are working with objects, initially, when you create an object, you're not actually really creating an object, you're defining it. You define what it is. So you're making a template that represents your own data type. Now, that always was like, well, how can I have my own data type? Everything's a number on the computer. That doesn't make any sense. Well, every number is different, but what if we could have a bunch of numbers together, like month, day, year, for a time object or a calendar object, and so on. So you can build these objects, but they actually are your own data type. They're just like an integer, float, double, any kind of data type that you've been working with implicitly. However, this one is, when you work with it, you got to actually create an instance of it, and that means that once you've defined it, then you can use it. But you can use it because it's a template. So you can create an instance called A and have another whole watch object or time object create a whole nother instance called B. So think about it as like making a data type, or defining a data type, and you can kind of think of it as like the blueprints of a house. And then you can take those blueprints and you can duplicate the house multiple times and call them house X, Y, Z. And each house has those initial blueprints, so that if you need to make any modifications, it's fairly easy to do. You can also think about it like a cookie cutter. You're designing a data type that has data inside of it and functions that act upon that data. That's your cookie cutter. And that object represents something you're modeling in the real world, like a calendar or a watch or a time object. Car objects, pet objects. Once you define that object, then you instantiate it and you make your cookies. Okay, so I want to get into a little bit more, because we've got actually 2 weeks on this. I want to get up to here today, but I want to, we may revisit these PowerPoints, but I want to get into actually having some fun. We're going to be using the init function is special and the str function is special, but that's something we're going to delve into right now. So let's get some Visual Studio Code going. Now we're going to do this properly. We're going to actually make this as a library, and I'm going to show you how to create the library that we're going to make, and we're going to actually make a watch object. And then what we're going to have to do is build accessors, and then we have to drive our object. We got to create instances of it and show that it works. So what we want to do is we want to begin with a main. So I've started with a main, but here's key, is because we're going to be importing this library that we're creating. We want to actually create the PI file right in the same spot, in the same folder as the PI file that we're using to access the library. So they have to be together in the same directory, just like when you open files. So what I'm going to do right here is I'm going to just create a quick folder, and I'm going to call this watch. Okay, now inside of the watch folder, I'm going to go ahead and create a new text document. You know what, we can do it that way, and rename it Pi. We could do it a couple other different ways, but you know what, let's use the editor. And let's do this first one. I'm going to do a file save as. and this is going to be my main. Okay, now I put that, I didn't put that in the watch folder. I need to put that in the watch folder, the folder I just created. So I'm going to put that in the watch folder, and I'm going to click save. Okay, now I look in my watch folder, and in my watch folder is my main.py, and I make sure that I'm up here and I see this, see users desktop, good, watch folder, main.py. So yes, I'm in the right folder. You want to always double check that, guys. All right, so let's now go to File, New File, and we're going to go ahead and do the Python. And we're going to save this one as, and this one's going to be our library. So we're going to call this watch, because we're going to have a watch class. We're going to call this watch.py. Okay, watch.py, and again, users, be just, desktop, watch.py. Oop, that matches up. Again, oh, yep, it all matches up. In my folder, they're both together. I'm editing the one file. Okay, we're good. We're ready to write some code. What I'm going to do is we're going to first start with a class definition. And you know what? I write in so many different programming languages that sometimes I just forget. 7-8 programming languages a day sometimes. So I usually forget some of the baser syntax. So we're going to cheat a little bit, and we're going to go grab a quick refresher. And I'm just going to type in Python objects just to get something to get my noodle and brain moving. Okay, so yeah, all right. So we got to declare it that way. All right. All right. So, and then we're going to have to implement an init function. Okay, now is this crucial? The tab is you need to be tabbed in, but here's the thing: is if we're going to actually create variables that are going to be part of this class, using the self dot is excellent. But first, actually no. First, we're going to call this watch, and then what we're going to decide on is what is the watch gonna. The watch is going to handle for hours and minutes. So I'm going to declare a watch variable. Now this is a special variable that is part of the class, and the watch variable is going to be created using, and we're going to use the self. So if you see in this example here, we have self.name. What that means is this name variable is part of this object. So remember, when we create objects, what we're doing is we're creating a box, and in that box we have variables, data, and then functions that will be implemented in that data. Now this is a very special function. It's called init. Okay, and we're going to look at that. Okay, now init is important because it is how, or it is a special function. It is actually called when you create an instance of watch. So it's called when you create an instance of watch. Well, how do you create an instance of watch? Well, we're going to get to that, but right now we're just defining what the watch is. That's all we're doing. We're not actually creating the watch. We're just defining what it is and what it has. And the watch has the ability to hold hours and seconds. So when you go to define the data types in your watch, those data types are added when the init function runs. So remember, this is an interpreted language. It's not compiled. So there's ways that they get around allowing it to be object oriented, and for that it actually has to be runtime when you declare your variables. So that's why we have to put it in the init function. And remember, the init function is a function that's automatically called when you instantiate a watch. Now let me demonstrate that. I am a Rolex. Okay. All right. So this is a function that we have called init in our watch. And right now, notice how the init has the 2 underscores and the 2 after scores. This is all Band-Aids type stuff because they're doing this after the fact, after Python was, initially developed. The self denotes that, or is the way that you can get access to your watch itself. Because here's the thing. When you're inside of the watch, you don't know what you've called the watch. So that's why you say self. It's kind of like my finger knowing my own name. And I'll demonstrate here in a second kind of how init works. So what we're going to do is we're going to actually create a watch here. And we're gonna say that the watch is going to run the init function, and it's just going to run the init function, and I'm gonna show how that actually behaves here. So, but before that we do that, before we can start testing and playing with our object, which this is kind of the lowest level of an object right here. It really has nothing other than the function that runs when you instantiate the object. And this might be incorrect, guys. I'm gonna have to come back and look at that. In fact, it might be just like that, but I'm not for sure. Oh, actually, I know why it's not incorrect, because I haven't imported it yet. Okay, so here's the thing is, if you have your object named the same as your file, you're good. You can just probably say import watch. Otherwise, you would have to say from my watch file, import watch. So this is a little shortcut. Otherwise, when you're importing this watch from main.py, you would have to say, I want something from watch.py or watch, and I want to import watch. Well, they shortened that up, and that's just because if you name them different, you could do that. But if you didn't, if you name them the same, then you should be able to get it to work with just import watch. And you see now that I have that capability. Watch is no longer being a stinker. So this is an instantiation of the watch. Now let's look at what happens. Because I'm not telling it to do anything other than just create the watch. Okay, so I'm going to go ahead and begin this. Okay, I figured. we're gonna get back to the PowerPoint here shortly. I'm gonna get into this little syntax error. But what's nice here is that we're actually able to import the watch. We probably don't have any issues other than just that one line of code. Okay. Interestingly enough, I had to go back to the old school way of doing it. From watch, import watch. I guess, just do it that way. From the watch file, import watch.py. Or import the object called watch. Okay, so now what I want to do is, now that we got this running, I run this and I say here, and then here is, hello, I am a Rolex. So what I did is I took Rolex, which is an instantiation of the watch object, And now that Rolex is instantiated and I can look at it. So I'm going to go ahead and run debug, and we're going to look at run start debugging. We're going to look at what happens to Rolex. Okay, so down here, what I did is I just did an add and I said Rolex. And what it's going to do is it's going to tell me what, you can also do that with locals and globals. Locals should pop up. But it's going to tell me what Rolex has after watches ran. And it looks like it just says not available. That's fine. It worked fine. What I want to do now is, if it can allow me, if the debugger is good enough, I would like to do a step into. Okay, now you see I stepped into it, and what it's running is it's automatically calling that init function. Now this is just like any other function with another name. You know, it just happens to have a special name, so it's not confused with any other function. That's why it looks so weird. That's all, just so that the interpreter doesn't confuse it with anything else. But it's just a regular function, but it's a special function that you give that special word. And what it means is that I'm going to contain the watch. And what that means is the watch has a name, because this defines it. But when it's actually running, when we actually create the watch, now the runtime code comes into the play of the object. And that is with this init function. That init function is automatically called when the watch is created. It's just part of what we call constructors. So an init function in another language, we call it a constructor. So go ahead and do some research on that. Now, the idea of this self, that we need because, number one, this is an interpreted language, so it's not compiled. So that means it won't work like other languages work. We have to get around things. And that's why we have this weird add-on thing called self that basically denotes the watch's name, which is Rolex. But the thing is when we're in the code of the object, we don't know the watch is called a Rolex, because that's all done out here in main. We don't know it's called a Rolex. So how do we refer to the watch as a whole when we're inside of the watch? And that's easy, because I just say myself. My finger knows what hand it goes on. It's the self hand. That's the idea of that self. It represents the whole watch as a whole, the whole object of the watch, just as you were to use it over here in the name Rolex. Okay, we're going to create another instance of the watch, and this is going to be I don't even know what a real horrible watch is these days. It's been so long since I've actually bought them. I'm going to create a Casio, I don't know, whatever. That's another watch. And so I'm using my cookie cutter template here. And that's what this is for. Once I create a watch, I can have many different kinds of watches. Now you're going to see that init function is now going to run twice for each one of these guys. And there is our init function. Okay, well, here's some special things that we want to do with a watch. We want to have some data that we have for a watch, and we want to send it that data. And we want to be able to work with that data later on. So what we have to do is we have to do things that we call getters and setters. And we also got to finish the init function. So what we're going to do is we're going to actually do the init function and the toString first. So this is going to be no longer done in our init function, because it's actually for us to send it information, which is the send it. We want to, when we create a watch, we want to be able to set the hour of a watch and the minute of a watch. And when we run init, we're going to have a variable inside of the watch called hour. And we're going to assign it to the hour that we send it. And we're going to do the same thing with minute. And what we've now done is we have a box, our object called watch, and inside of it, it has a function called init. And we've declared two variables that belong to the watch, hour and minute. So now we can have functions that act upon that hour and minute. And here's the key. You do not have to pass the hour and minute or receive the answer from that function that acts on the hour and minute. It can directly act on the hour and minute without any, it could just do it because it's there in the same scope of the watch. And it has access to the watch's hour and the watch's minute. So this is actually the watch's hour, the watch's minute, or self. This is the hour that we're passing through the function, the init function, to set to the watch's hour and set to the watch's minute. That's what that key self is for. We're like saying Rolex.hour equals hour. Rolex.minute equals minute. And then for the next one, we say Casio.hour equals hour. Casio.minute equals minute. It's the same thing. So we now created variables that we can use for functions that we create. So now what we do is we want some way to output this whole object, and most of the data it represents, or just the data that we want to output when we do a print of watch. Before we get into that, let's demonstrate the init function. I'm getting ahead of myself a little bit. I'm going to go ahead and set a breakpoint here in main. I'm going to show you that we're going to send it, I believe, hours and minutes. 12, whatever. 12 and 56, 12 and 56, 12 or 11 and 34. So one is 11:34, the other is 12:56. Notice I'm sending the hour and the minutes in separate arguments, and I'm going to set a breakpoint so we can see those coming in, that 12 and that 56 coming in. So I'm going to say start debugging. Now I'm going to instantiate my Rolex. I'm going to do a step into, and we can see that the hour comes in as 12, the minute comes in as our 56. We're sending the hour of the watch to the hour that's passed in. So we can look at self and look at kind of what's going on here. Okay, now once it sets that for the Rolex, now look at our previous watch that we had held for our Rolex. We can break it down, we can look at it. Oh, it worked, cool. I'm driving my object now. And if I go to Casio and add a watch for that, it's not going to pop up yet, but because I haven't ran this line of code yet. So, but once I do a step over here, that Casio is going to be created. The program ran before it showed, but that's okay. So now I want to be able to show the user that data. And to do that, I'm going to define a special function called toString. And here's the thing with this function. You use it by doing just this, print watch. In main. I'm in main now. I'm going to say print watch. And we don't use watch. We use the name of the watch that we've actually created. And I say print Rolex. And what I'm saying is print the watch. But the print function doesn't know how to print the watch. So we have to tell it how to print the watch. And that's where this special toString function comes in. And it's special again. See, it's got the forward and trailing underscores. And that is to denote what function is called when the print function is run. And all you need to do with this is return a string that is your data. And so I'm going to take the stringed value of hour because I did not send it in as a string, which is appropriate. And then I want to add on a space to it. Oh, I just want to print the hour. Oh, I might want to set hour here. Oh, you know what? Let's just do it like the clock. Let's just do a colon here. And then we'll add self.minute. Okay, good. Okay, so now when I do a print watch, it's going to output the hour and minute for that watch. So let's go look at actually how it does that. And then we'll look at it in the debugger too. Okay, I'm going to set a breakpoint here. This time we're going to be able to see the Casio in our debugger, or in our watch. Okay, so I'm going to step over. Here's my Casio. It's good. Here's my Rolex. It's good. Guys, use the debugger, please. And I'm going to be harping all the time. All right, so I'm going to print my Rolex. I'm going to do a step into here, just because I want to see what's going on. So I call print Rolex. And it doesn't like me. It must have done something wrong. I'm going to have to come back to this in a little bit, guys. I wonder. Yeah, I probably didn't do the two-string correctly. I'll be right back. So yeah, I was writing a different programming language. So the two-string is actually __str. Two-string is a different language for Python. All right, so now we can work with the two-string method to output. So let's go ahead and look at that behavior. Start debugging. And I'm going to step over. Now I'm going to print my Rolex now. I'm going to step into and see it calls our toString method. And all it does is return the string value. It looks like I'm probably going to have to modify a few things here. But that probably did not do a very good job. So a few little modification. Few little things. str of converted hours to a string plus the colon, and then convert that one to a string. All right, there we go. Now we're ready to test. Okay, start debugging. All right. Run, start debugging. Okay, you don't like me today. All right, there we go. There we go. All right, so step over, print our Rolex, step into. Now we print it. We would just build the string and return it to the print function. That's all we're doing. And what we can do is we can actually just look at what we're printing by selecting that whole thing and just do Control-C, copy it. Go over here to your watch and Control-V. Looks like I need to do a better job of my copy paste here. Control-C, Control-V. There we go. And you can see what it represents beforehand in your watch if you want to. And there's the output, 1256. That's what's being returned to the 1256 is what's being returned to the print function. So we do another step over. We go back to the print function. Oh, it was 1134. Excuse me. Oh well. It was the previous value of what it was before. Okay. So that's kind of the basics, the very small basics, but not really. There's one last thing. For every variable you have in here, you must have an accessor. And because you don't want to allow this variable to be changed. And I'm only going to do it for one, guys. I'm not going to do it for minute. You would have the same two functions and the same tasks for hour and minute. Okay. Now the reason why we want to control access is so that we can surround it with if statements so that somebody doesn't set it to 0 and fry a machine somewhere. Well, that's if our library is accessing hardware. We want to control access to our data. This is the main reason why we're doing everything, is that data. So we want to put if statements in there and only allow them to change something. So remember, we're programming from another programmer. They're going to use this watch, and they're going to want to set the hour for the watch. And then they're going to want to get the hour for the watch. So what we want to do is we want to build a function to set the hour for the watch, and then we're going to take that and we're going to run the same code that we're using for our checks, for our validation inside of the init function. So we're going to say set hour, and this one has to have itself and then the hour that we're going to pass to it. And the hour that we're going to pass to it is what we're going to want to set the hour to. This is what the user is going to use. And then we're going to say self.hour equals hour. But I don't want to do that yet. I want to check. I want to say, see if hour is less than 25 and hour is greater than 0. That's the only time I want them to be allowed to set the hour. So now that, hey, I've got that working here. Oh, I'm writing another code again. Okay. Now that I've got that working here, what I want to do now is I want this same if statement to be working here. But there's no reason to rewrite it. So what I can do is I can just run self.setHour here instead and run hour through, because it's set hour has already got my my validation. So I shouldn't have to rewrite that, and I'm not going to. Oh, and let's see if we've created this correctly. Okay, I think we got a little bit of a problem. Something about unknown word set hour. Okay. You know what? Let's do this. Let's just come back to this later. And let's just test the getters and setters. You can put the if statements up here if you want to. We may get further along on that. Let's just get this working first, and then we'll go in and make it work up here. All right. So when I use this in main, I'm going to go back here and I'm going to say, okay, well, Casio is no longer, hour is no longer 11. So I want my user of the object to be able to set the hour, And with the hour that they set, I want them to put in a number. And then when I do another print of Casio, that should take care of it. Okay. So it looks like I got a syntax error that I'll have to come back and fix here in a little bit. Let's see. Oh, no. Looks like it's doing fine. It must not... something it's not liking about it. That's fine. It looks like the set hour function is working. And then what I want is I want a get hour function. You know what? Let's do a quick search and just look at Python object function. You know, some examples of that. I'll just do Python object example. And what we can do is we can kind of look at our example and see where we're at. Okay, we've got a lot of those behaviors. We don't have a lot of There we go. Here's a function just out in the blue. You know, I think we're good. I think that's a good function. So let's go look at it one more time, syntax-wise. Okay. We'll call it good. All right, now the other thing that your user of your object may want to do is they may want to do getHour. And that is where you return the value. Now this is going to be an empty return. You got to send the self, but all it's going to do is just return self.hour. Okay, now these are the attributes, and let's test this. All right, we're going to go ahead and test this. Okay, so I'm going to go to main, and we're going to set an hour, and then we're going to go to Casio.getHour. But what we're going to do is we're going to just print it. Okay, now I'm going to set the breakpoint here, and we're going to start debugging. Okay, I'm going to do a set hour, and I want to change it to 10 from 11. I'm going to just trace it through. I'm going to do a step into. It comes in. Hour has our new 10. We say, hey, does hour pass muster? Yes, it does. Go ahead and set the hour in our object. We've properly protected it. This is called information hiding, and there's a reason for it. Because we just want to give somebody a car to drive, a beautiful, wonderful car. And nobody who gets a car from us wants to open the hood. When I get an object from somebody, I don't care. I just want to use it. Okay, so now we get the hour. Step into, and it just returns the hour. That's all it does. Okay, and then that is what's printed. And there's the 10 from the getHour print. And then, of course, we got our Casio print at the very end, 1034. Okay, guys, these are the main components of everything you need to do to work with an object. This is what I want to see in every object that you author. I want to see accessors for every data type. That means that you should have 4 accessors here. 2 for hour, 2 for minute. I want to see an overloaded string object that prints your object. And you also have to have the init. You just can't do anything without it. But these are the mechanics of a good object. And when you drive it, I don't care about user input. You notice how I am not asking the user for the time. I don't care. I want to test the object. So I'm just sending the data in and printing it. There's functions that you'll run on your object that may process information, all that good stuff when you start working with your objects. Okay, guys, thank you.